How do we perceive the world? What if we want to record it with some movement? More detail, distance, or just the back of this apple?
We would like to introduce the concept of 3D modeling and its relationship to our daily life. 3D modeling is widely used in various industries to visualize and illustrate people's ideas. In movies and games, we use 3D models to show the audience fictional characters and scenes in extreme detail. We could produce continuous frames using 3D software instead of drawing every single one. While in engineering and architecture fields, 3D models are built to detail out designs, testing, and getting feedback before the production phase. It helps people to visualize projects fast and easy. Would be a time-consuming process in large-scale projects. Imagine someone would need to create a model for every single building in a city to bring them into the digital world. It could also be hard to pick up the changes happening in the city. If we are interested in illustrations of our city updated frequently, it would take too much work. Similarly, 3D models by hand are nice, but not so helpful when we just want some rough but quick ones to play with, which then leads to a solution for a simpler and quicker mobile 3D modeling experience.
Thinking about copying a document.
Would you type out every single letter on a paper or just scan and copy it? Likewise, to easily build a city, we could take advantage of 3D scanners. When we put scanners and mobility together, we can have any model we want, anytime, anywhere. Nowadays, we have 3D scanning joints to easily access high-fidelity models of landscape. It uses LiDAR as a sensor to record coordinates of objects in 3D spaces and transforms them into 3D models. The possibility of 3D modeling from mobile devices enable us to do a lot more. We are on the precipice of a modeling revolution, where recent technology and those in the development set to be the game changers in the world of 3D modeling. Modeling is a big technical field. Although the results of 3D models are created by detecting the distance between the device and a single point on the surface of an object, the techniques behind them were very different. By combining the data with other sensors such as GPS, accelerometer, and camera, it computes 3D models using the coordinate data and colors them with images taken. Two common ones are mobile laser scanning and photogrammetry. Mobile laser scanning is an approach widely used in current settings. It creates models based on a point cloud where each point represents a tiny bit of the object's surface. To construct each of these points, the distance from the device is calculated by taking the traveling time of the laser beam shoot and bounce back. It then assembles the points in the system with aid of geographic information describing the movement of the device itself to prevent errors. While the drawback is the laser might not be so helpful under bad weather conditions as fog, cloud, or other obstacles might affect its accuracy. And then we have another approach, which is photogrammetry. Different from MLS technology, it obtains information just like how humans do. While MLS interprets distance information from traveling time of laser beams, photogrammetry analyzes and studies distance from a single source, which is the camera. By doing so, photogrammetry does not rely much on other sensors. Hence, it leads to a more simple hardware and hence lowering the cost to do 3D modeling. However, as cameras played a major part of this approach, light conditions are critical to achieve good quality models. Now we already have the idea of the two major approaches to 3D modeling from mobile devices. But how do we take advantage of mobility to help our daily life? There are few usages in urban areas already. The first one is how we use the convenience of mobile 3D modeling to reduce people's workload in road inventory. And the second one is autonomous vehicles. In the first case, we use mobile 3D modeling to aid road inventory. Traditionally, issues concerning road conditions are raised by people's manual reports, which means it is time-consuming and not responsive. Therefore, to increase the efficiency, people started to use mobile 3D modeling techniques. Mobile laser scanning technology is installed on operating vehicles, which allows us to achieve reliable inventory management in normal traffic speed. Another approach of photogrammetry is also available and would be cheaper and easier to operate. With the help of additional light sources, a camera-based system produces sufficient information to be reported and could even be used to alert autonomous vehicles on the road. Another fascinating threading technology is autonomous vehicles. As mentioned, autonomous vehicles also rely on information from 3D models. Since detecting the environment is critical to autonomous vehicles, good quality models could help in ensuring safety and accuracy. To achieve this, MLS and photogrammetry is again utilized to address the concern. MLS, together with photogrammetry, is used to provide a higher quality and faster response. It provides the computer of vehicles with the information about the surrounding environment. As distance data is recorded with laser scanners, it could help to maintain a suitable speed and automatically follow the previous vehicle. An intelligent driving system also obtains photogrammetry data to analyze extra information such as signage and lines in this case. However, some manufacturers choose to use a plain photogrammetry system. They believe that simulating the way people drive with eyes rather than other senses is the proper solution. In this case, all information is interpreted by a number of cameras installed to get a rich picture of the environment.
3D modeling technology is changing the life of every ordinary people. With the development of time, the equipment involved in 3D modeling is getting smaller and easier to use with mobile computing technology. This will make 3D modeling technology more closely related to our lives. Imagine a future where forensics could use this technology to record crime scenes using mobile phones or other handheld devices. Isn't it much more intuitive than just a photo? Or maybe you are driving to a really important date and you get into an accident with someone else. You can just pull out your phone and record every single piece of information through 3D scanning technology, saving everyone's time. Would you rather avoid an accident? Future urban planning may connect every single device to enhance the traffic. Maybe your car, but not limited to your car. Laser scanning and photogrammetry technology will apply everywhere, and your navigation app will receive the results from the cloud, so that you can avoid the traffic jams, predict the accident that may happen, and update the road closure or road maintenance. 3D modeling is not limited to 3D scanning. It is also used in various fields of our daily life. As we know, cloud computing is now a popular field. People can use more computing power without carrying heavy equipment because of cloud computing. Hence, it is also very suitable for the field of 3D modeling. The most important thing is more and more people using 3D modeling. There will be more related jobs. If the ordinary people uses cloud computing, they only need a laptop as thin as a book or even an iPad, and they can build or modify the 3D models in Cafe, just like using Microsoft Word.